Okay, hi guys. So in this lecture as well, we'll be discussing some more examples on Friedel craft acylation. So let's get started. So we have something like this, and you have to prepare the major product from the reagents. We have something like this. I think we have seen this example in previous uh, uh, lecture, but a similar example in previous lecture, but where we had this structure, and now we have this structure. Okay. Oops. Yeah. Now we have this structure. Okay. So what would be the output of what would be the product of what would be the major product for this reaction? Obviously we will get, in presence of H plus, what will happen is, again we will first get this product in which we have a positive charge, positive charge here on this carbon atom, and OH is formed here. This benzene ring will actually attack on this carbocation and will form something like this structure. We will have this as the final product. Okay, this is directly attached to OH. Okay, so now the next set of questions. Before starting the next set of questions, I just want to make a note here that no Friedel-Crafts acylation or alkylation, or rather no, in a general way, no Friedel-Crafts reaction actually takes place in deactivated rings. Okay, now the next set of questions are, you have to prepare the following compounds by Friedel-Crafts reactions. Prepare the following by Friedel-Crafts reaction. Okay, so the first question is, you have to prepare this. Okay, so how would you prepare? You can take a phenyl ring, a benzene ring. You can take something like this in presence of, again, AlCl3 to form this product. Okay, this is one of the ways. You can also have a second way in which you can have either in presence of AlCl3. So what would happen in the first step? In the first step, we will get something like this, that we will have positive charge on this carbocation, and we have something like this, and again on reaction with AlCl3 and benzene is also present, we will again have CH2 dot CH2 plus, and benzene can again attack on this formed carbocation. But is this better than the first uh, part, that we can actually form this compound from this reagents? Is it better than the first point? I don't think it's better, because in this case we are having Friedel-Crafts alkylation, right? And in this part we are having Friedel-Crafts acylation, and Friedel-Crafts acylation is always better than Friedel-Crafts alkylation, because polyalkylation and rearrangement can take place in Friedel-Crafts alkylation. Now in this case, what can happen in a rearrangement? If this compound undergoes rearrangement, this phenyl ring would have a better, would be migrated to this positively charged carbocation so as to form a IIT cation here, and we'll get something like this. Okay, so now if it actually gets rearranged, and this benzene ring attacks on this carbocation, will again get something like this. So again we get the same product as desired, but had it been something like different, then the rearrangement would have given us some different product. Okay, in this case both are equal, and even if the polyalkylation even if the rearrangement take place, we would get the same product. Okay, so we can derive the product from both the different ways. Okay, so in this case Friedel-Crafts acylation is equal to Friedel-Crafts alkylation, because even if the rearrangement take place, and what if rearrangement doesn't take place, then also we'll get the same product. Okay, this was our product. So in this case you can prepare in either of the ways. Second question is, you have to prepare this. So the only way to prepare this is you have to get something like this. In presence of AlCl3, you will get this product. This is also acylation only. You have to prepare this product. So how can this be okay, there is no Cl here. Okay, so how can you prepare it? So one way to prepare this is, you can have this ring. Okay, this ring with okay, and you can have presence of AlCl3. Okay, and this would be obviously directing towards any of the four positions. So even if it attacks at at any of the four positions, we'll get the same product. We can actually rotate that product and it would be identical to the product that is required. So we'll get something like this. And is there any other way? Yes, there is. We can have something like this. And how many carbon atoms are there? 1 2 3 4, right? 1 2 3 4. Okay, we can also prepare this with this reagent. Again AlCl3, and we'll get some H plus later on. Okay, again this product would be formed. Let's see another example where we have to produce something like this. So how can you produce this? We can obviously get something like this as our, how many carbon atoms are there? 1 2 3 4. 1 2 3 4. Okay, now again we can pass it in presence of AlCl3. Friedel-Crafts acylation will take place. Okay, and this ortho position will be attacking to this formed carbocation to form a 6-member ring. Okay, and then the product will be formed. Okay, so let us take some more examples or another set of questions in which you have to identify the unknown. Okay, and the first example is, we have a benzene ring and we have a reagent A in presence of AlCl3. We get something like this. Double bond O and double bond O. So what is A? So obviously, as can be inspired from the previous example, A could be this one. How many carbon atoms are there? 1 2 3 4. 1 2 3 4 are there, and double bond between 1 2 1 2 and 3, between 2 and 3. Okay, we can also have it as something like this. We have Cl, C double bond O, 1 2 3, 1 2 between 1 2 and 3. We have a double bond here. Okay, and then we have 2 3 4, 1 2 3 4, C double bond O OH. Okay, okay, we can also have A as this. So with this we come to the end of this lecture. In the next lecture we'll be seeing some more examples in which you have to identify the unknowns, and then we'll be taking on nitration part. So till then, good luck and goodbye.